The secret behind the Kawasaki Ninja H2R's insane power isn't its speed. It's the fact that it's banned from public roads. Now, this restriction didn't hold it back. It unleashed its true potential. Imagine an artist breaking free from strict rules to create something extraordinary. That's what happened here. In this in-depth review, we'll explore how ditching road regulations became the ultimate design freedom. From its ear-splitting exhaust to race-only tuning, every detail was engineered for pure, unrestrained performance. Get ready to break down what makes this engine not just powerful, but untouchable in the world of high-performance machines. But before we get started, consider subscribing and hit that like button. The Kawasaki Ninja H2R is no ordinary motorcycle, and the key to its unparalleled performance lies in one surprising fact: it's banned from public roads. While many assume that this is due to its raw speed or its perceived danger, the actual reasons are far more technical, and they've become the greatest advantage for this machine. Regulations designed to keep street-legal bikes safe and clean are precisely the constraints that the H2R was never forced to follow. By ignoring emissions and noise rules, Kawasaki unlocked capabilities that no legal bike could ever hope to match. Let's break this down. Road-legal motorcycles must comply with strict environmental and noise regulations, such as EPA standards in the US and the Euro 5 in Europe. These rules require components like catalytic converters and oxygen sensors, which limit pollutants but also restrict engine performance. The H2R, however, skips these entirely. Without a catalytic converter, an essential device for cleaning harmful emissions, but one that also creates back pressure in the exhaust system, the H2R's straight-pipe exhaust allows air and fuel to flow freely, delivering far higher power output. Imagine an engine designed like a Formula One car, where every drop of power is unfiltered by limiting components. Kawasaki also tuned the air-fuel mixture for maximum performance. Street-legal bikes are forced to run leaner mixtures to reduce emissions, but this often leads to higher engine temperatures and reduced efficiency. The H2R avoids this trade-off by running a richer mix, which keeps the engine cooler during high-boost conditions and enhances overall performance. Building on this freedom, Kawasaki also ignored the noise restrictions that typically apply to motorcycles. For example, EU regulations cap motorcycles at around 80 to 82 decibels at specific engine speeds, roughly the volume of a passing truck. In contrast, the H2R roars past 120 decibels at full throttle, a sound level comparable to standing next to a rock concert or even a jet engine. This isn't just about being loud for the sake of it. The engineers designed the exhaust system to minimize back pressure, boosting throttle response and power output. The result is an exhaust that's unapologetically aggressive, like ripping a page out of the rulebook. Some racetracks even issued warnings or imposed limits for riders, underscoring just how extreme the H2R's design is. The straight-pipe exhaust exemplifies how removing constraints enhances performance. Unlike street-legal motorcycles that must balance emissions and noise reduction, the H2R's exhaust is all about efficiency. Without a catalytic converter to slow airflow or mufflers to dampen the engine's roar, the system allows gases to escape faster and fresh air and fuel to cycle more efficiently. This translates to smoother throttle control, quicker acceleration, and an unmistakable engine note that screams raw power. No road-legal bike could ever get away with such an unrestrained setup. When emissions and noise constraints are removed, the result is pure engineering freedom. Kawasaki wasn't concerned with meeting regulatory standards or accommodating city commuters. Instead, every decision, from the exhaust design to the engine tuning, was focused on one goal: performance. This freedom also meant that they didn't need to compromise on practicality, like low RPM fuel efficiency or reduced noise levels. The H2R is built to deliver uncompromising power on the track, unrestricted by the limitations that govern street-legal bikes. This design philosophy makes the H2R more than just a fast motorcycle. It's a statement about what's possible when performance takes center stage. Its banned status isn't a limitation, it's a badge of honor. The H2R could have been just another superbike if it had conformed to the same rules as everyone else. Instead, Kawasaki created a machine that defies limits altogether. One striking comparison is how the H2R stacks up against its street-legal sibling, the Ninja H2. The H2R generates over 310 horsepower, while the emissions-compliant H2 produces significantly less due to regulatory constraints. Now, every compromise made to make the H2 street legal highlights what the H2R gains by ignoring those restrictions. By stripping away the regulations that tame modern motorcycles, Kawasaki unleashed the full potential of cutting-edge technology. The engineers didn't have to balance conflicting priorities. They only had to focus on unleashing the bike's true capabilities. That's what makes the H2R stand out. Not just as a motorcycle, but as a demonstration of what happens when creativity and performance are allowed to thrive. But this level of freedom came with some challenges. An engine like this faces forces that could destroy it under the wrong circumstances. So, how did Kawasaki design an engine capable of handling such extremes? That's where the heart of the H2R, the Supercharger, comes into play. Let's explore what makes that next-level engineering work. The Supercharger in the Kawasaki Ninja H2R engine is the key to its jaw-dropping performance, a testament to what can be achieved when engineers are free from traditional design constraints. This compact yet powerful device spins at an incredible 130,000 revolutions per minute, faster than most jet engine turbines. It's a bold engineering feat that highlights Kawasaki's audacity to push boundaries in pursuit of speed and power. At its core, the H2R employs a centrifugal-type supercharger, a rare choice for motorcycles. Acting as an air compressor, it forces more oxygen into the engine cylinders, a necessity when chasing over 300 horsepower from a 998cc engine. Natural aspiration simply couldn't achieve this level of power, so Kawasaki turned to forced induction. The centrifugal supercharger offered the perfect balance of efficiency and reliability for this extreme application. What sets the H2R supercharger apart is its unique drive system. Instead of being directly driven by the engine, it uses a planetary gear drive, a marvel of precision engineering. Like the intricate gears of a finely tuned watch, this system multiplies the impeller's speed far beyond what the engine crankshaft could achieve alone. For every rotation of the crankshaft, the gear system spins the impeller 9.2 times faster. This ingenious setup allows the supercharger to reach its astonishing 130,000 RPM, compressing enough air to meet the engine's immense demands. Breaking this down further, the planetary gear drive ensures the impeller operates at peak efficiency without compromising reliability, a critical factor in such a high-stress system. The impeller itself is a masterpiece of engineering, developed with input from Kawasaki's aerospace division. It's 3D machined from forged aluminum, combining lightweight properties with the strength needed to endure the immense centrifugal forces at maximum speed. Its aerodynamic design is equally remarkable. The shape and angle of the blades are optimized to compress air with maximum efficiency, pumping over 200 liters of air per second into the engine. To put that into perspective, it's enough air to fill an average-sized bathtub in less than a second. This rapid flow of compressed air feeds the engine with breathtaking efficiency, delivering the boost pressure essential for the H2R's unparalleled performance. Speaking of boost pressure, the supercharger generates between 20.5 to 21.3 psi. Those are levels typically seen in turbocharged high-performance cars rather than motorcycles. This massive pressure forces more air into the engine than it could ever inhale naturally, enabling an equally high volume of fuel to be burned. Together, this combination of air and fuel produces over 310 horsepower, transforming the H2R into an engineering marvel. Now, one of the most impressive aspects of the supercharger is its precision. Unlike some forced induction systems that deliver power in unpredictable bursts, the H2R's centrifugal design ensures a smooth, linear torque curve. This means the power delivery feels consistent and controlled, even as the RPMs climb. For a machine designed to dominate the track, this smooth delivery is crucial. It allows riders to push the bike aggressively without worrying about sudden surges of power disrupting balance or traction. Another standout feature of the H2R supercharger is its compact, efficient design. Most forced induction systems require bulky intercoolers to cool the compressed air before it reaches the engine. However, Kawasaki's engineers designed the H2R supercharger to minimize heat buildup during compression, eliminating the need for an intercooler entirely. This innovation not only saves weight and space, but also streamlines the airflow path, making the engine more responsive. The result is a lean, efficient system that delivers exceptional performance without unnecessary complexity. The supercharger isn't just a component. It's the centerpiece of the H2R's engineering philosophy. Every part of the engine, from the pistons to the valves, was designed to work in harmony with the immense pressures and temperatures it generates. Without the supercharger, none of this would be possible. It redefines what a high-performance motorcycle engine can achieve. This groundbreaking design reflects Kawasaki's ability to think beyond conventional automotive norms. By leveraging aerospace expertise, advanced materials, and innovative mechanical designs, they created something truly extraordinary. The Supercharger doesn't just build power. It does so with elegance and efficiency, even under some extreme conditions. But while the Supercharger enables the H2R's astonishing power, the engine itself must withstand forces that would destroy most standard designs. So, how does Kawasaki make an engine capable of handling such immense stress? The answer is even more impressive. How does the H2R's engine endure the immense forces it generates? This question lies at the heart of what makes Kawasaki's engineering so remarkable. Producing over 310 horsepower from just 998cc is no small feat, and it puts the engine under stress levels most street bikes will never encounter. For the H2R, generating power isn't enough. It must also endure it. Let's explore how Kawasaki designed this engine to operate at the edge of possibility. It starts with the materials. The H2R uses forged aluminum pistons, which are stronger and denser than the cast pistons found in most street bikes. This strength allows them to withstand the immense heat and pressure generated by the supercharged engine. Cast pistons may be cheaper, but they can't handle the extreme conditions the H2R faces. Forged pistons are a critical choice, ensuring the engine can perform reliably under extraordinary stress. Moving from the heart of the engine to its supporting structure, the crankshaft is another key component. In the H2R, it's machined from a single block of high-strength steel, a billet crankshaft. Think of it as the backbone of the engine, built to handle the immense torque and high RPMs produced by the supercharged motor. This process enhances both strength and precision, making it essential for maintaining durability and performance. Without it, the engine couldn't reliably sustain such extreme power. The connecting rods also play a pivotal role. These components, crafted from lightweight yet strong materials like titanium, are engineered to reduce reciprocating mass while withstanding the intense forces of combustion. Titanium's combination of strength and lightness makes it ideal for an engine spinning at such high speeds. In contrast, the steel rods used in most street bikes would be too heavy and unable to endure the H2R's extreme demands. By using titanium, Kawasaki optimized both performance and durability. The cylinder head and valve train further elevate the engine's capabilities. Intake valves, made from lightweight stainless steel, and exhaust valves crafted from heat-resistant Inconel ensure these components can withstand high temperatures and pressures without failure. Valve springs are designed to prevent valve float, ensuring smooth and efficient operation, even at the H2R's sky-high RPMs. These details, while easy to overlook, are essential for maintaining power and reliability. Airflow design in the cylinder head also plays a crucial role. Carefully engineered intake and exhaust ports maximize airflow, allowing the engine to breathe freely and operate efficiently under extreme loads. High-lift camshafts and wide valve timing overlap further enhance this airflow, striking a rare balance between power and efficiency. These refinements ensure the engine remains predictable and responsive, even at its limits. Managing the immense heat and pressure generated by the H2R requires an advanced cooling system. Large, efficient radiators dissipate heat, while oil jets spray directly onto the bottom of the pistons to regulate their temperature during high-performance use. A high-flow oil pump ensures every critical component receives proper lubrication, reducing friction and maintaining performance over time. The one-piece cylinder and upper crankcase are designed to maintain structural integrity, even under the immense forces of combustion. Together, these systems act as the unsung heroes, ensuring the engine stays stable and reliable during the most demanding conditions. Even the combustion process is optimized. The flat piston crown, developed with input from Kawasaki's gas turbine and machinery company, prevents knocking and maintains controlled temperatures and pressure levels during each cycle. This precision ensures reliable, high-power output without compromising durability. Large coolant passages surrounding critical areas like the cylinder head and spark plug holes further enhance heat dissipation, allowing the engine to maintain peak performance. Every component of the H2R's engine is designed with no compromise. From high-strength materials to sophisticated cooling systems, each innovation works in harmony to create a machine capable of producing 310 horsepower reliably. Now, this durability isn't about numbers alone. It's what allows Kawasaki to push the H2R's performance to the edge without fear of failure. When paired with advanced aerodynamics and electronics, it's clear that the H2R isn't just fast, it's engineered to dominate. Imagine strapping into a cockpit rather than settling onto a motorcycle seat. That's the sensation the Kawasaki Ninja H2R delivers, a machine that feels more like a spacecraft than a bike. Its design is the key to this extraordinary experience. While most motorcycles stick to traditional engineering, the H2R takes inspiration from Kawasaki's aerospace division, applying cutting-edge aerodynamics and advanced systems to redefine what's possible on two wheels. Aerodynamics are at the heart of the H2R's performance. At speeds north of 200 miles per hour, managing airflow becomes critical. The carbon fiber winglets mounted on the fairing are engineered to generate downforce, pressing the front tire firmly against the track. Without them, the front end would destabilize as the bike approaches its top speed. These winglets work much like airplane wings in reverse, creating stability rather than lift. Kawasaki's aerospace expertise shines here, ensuring the winglets not only add stability but also minimize drag. Complementing them is the aerodynamically shaped rear cowl and chin spoiler, which balance airflow across the entire frame. Every curve and angle of the H2R is optimized to cut through the air efficiently, allowing it to harness its immense power without being hindered by wind resistance. Even the advanced electronics on board feel like something out of an aircraft. At its core is an inertial measurement unit, or IMU, which functions much like flight instrumentation, tracking movement in 6 degrees of freedom. This data feeds into the bike's electronic systems, enabling real-time adjustments to traction control, cornering management, and braking. The result? A ride that feels composed and controlled, even when pushing the limits of speed. Kawasaki's traction control, or KTRC system, is a perfect example of this precision. It uses sensors to predict rear wheel slippage and intervenes before it becomes unsafe. With 9 adjustable modes, riders can tailor the system to match track conditions or personal preferences. Instead of reacting to problems, the system proactively maintains stability, whether accelerating out of corners or hitting straight-line speeds. This integration of technology makes the H2R feel intuitive, letting riders focus on the thrill of the ride without being overwhelmed by its power. The braking system is equally advanced. The Kawasaki Intelligent Anti-Lock Brake System, or KIBS, is designed specifically for high-performance applications. Unlike standard ABS systems, KIBS calculates optimal braking response based on speed, lean angle, and other dynamic factors, ensuring precise control even during aggressive deceleration. This level of sophistication ensures that the bike remains stable and predictable, even when slowing down from extreme speeds. Mechanical aids like the quick shifter and electronic steering damper further enhance the riding experience. The quick shifter allows for clutchless upshifts and downshifts, ensuring seamless power delivery and stability during gear changes. Meanwhile, the Öhlins electronic steering damper adjusts its damping levels based on speed and input data, providing confidence whether navigating sharp turns or maintaining control at high speeds. While the H2R's performance is its centerpiece, even the smaller details reflect Kawasaki's obsessive attention to innovation. The self-healing paint, for instance, repairs minor scratches on its own, maintaining a flawless finish. Though a small feature, it underscores the meticulous care poured into every aspect of the bike's design. Ultimately, the H2R is not just about raw numbers like top speed or horsepower. It's about how every element, its aerodynamics, electronics, and mechanical systems, works in harmony to create an unparalleled riding experience. This isn't merely a motorcycle, it's a technological marvel, a machine that combines power with precision, making the extraordinary feel accessible. Riding the H2R feels less like handling a bike and more like piloting a spacecraft, where every component is designed to push the boundaries of performance. The Kawasaki Ninja H2R isn't banned because it's dangerous. It's banned because it defies every rule that governs road-legal motorcycles. By rejecting emissions limits, noise restrictions, and countless other regulations, Kawasaki unleashed a machine that prioritizes pure performance. This boundary-breaking design pushes the limits of what's possible when innovation is truly uninhibited. In the world of rule-bound machines, the H2R is a rebel with a cause, a glimpse into the future of performance where technology outpaces regulations. What if tomorrow's machines could shatter all limitations? That's a question only time and the relentless drive for innovation can answer. Uncovering the secrets of engines like the H2R takes a lot of research. Now, if you found this video informative and valuable, consider hitting that like button. It really helps the channel grow and allows us to bring you more content like this. And of course, subscribing ensures you never miss out on our latest explorations.